All right. So this is a video tutorial about how to make a brick wall. It's actually super simple. If you just look at the Rhino file, in fact, I don't need the ground. I can delete. Okay. So this is the brick. Simple like that. This brick is actually I made this by a mesh. So if I make a selection, you can see Rhino will tell me this is a mesh rather than a polygon, rather than a surface. This might be the technique you already know. In Rhino, when you create geometries, you can either create as a solid, it's basically a multiple surface, or you can create a mesh. So if I do a box, there's no much difference, except the mesh is easier to compute. So here, if I create a mesh, I can actually do it here. Is this? There's a mesh. Create polygon mesh. I can create a box, right? Which is here. You can also do a solid, and then you can do a box. All right. So there are many different ways you can create a brick. I prefer use mesh just because a mesh model is a little bit easier to compute. When you have like hundreds, thousands of bricks, it's very fast to calculate. But for solid, it's taking time. So that's a tiny thing I want to just make it clear. This is a mesh box. Okay. And also I see there's a curve here, right? So first thing I want to do is, if I want to lay the brick to a wall, I need some kind of guideline, right? It could be a straight line, could be a curve. The goal is I want to just make the brick follow the curve. That's the easiest way I can, create a wall. So in Grasshopper, if you want to do this kind of operation, let me just disable everything. Click this guy, you can disable the component. So basically, it's like a phrase. It does not compute anymore. It became gray color. I will show you my first definition. I will select that, middle button click, and enable. So they will be computed. All right. I will explain this piece by piece. So number one, if I click the green box, the green bucket, you can see the first thing I did is I load this mesh into this equation, right? So the mesh is actually the component in Grasshopper. You can grab a random geometry into Grasshopper environment. So this is the mesh. And then I have another guy here, which is a curve, right? Because I want to take the curve into Grasshopper as well. So I take the curve, which you can see is a green color. And also, I have this kind of tiny icons here. If I roll over, the name is reparameterize. Right? In fact, if I right-click this component, I can disable or enable the reparameterize. I want to explain a little bit what exactly is this. Reparameterize basically is recompute UV values. All right, in the surface, it has UV values 0, 0, right, in one corner, 1, 1 in another corner. So this is like a coordination system for the surface. So that's a two-dimension, U and V. In a linear geometry, like a curve or a straight line, you only have one value, right? It's a one-dimension value between 0 and 1. That value is actually a t value, right? It's a t value between 0 and 1. So 0 is the start point. 1 is the end point. So if I give you a t value as 0.5, which point is that? Is the center, right? The midpoint along that curve, right? So reparameterize basically will force Grasshopper to put 0 at the beginning and 1 at the end. All right. If you don't do the reparameterize, in some situation, the endpoint could be 2 or 3. It just depends on how you build the curve. So it could be messed up the whole equations. So you want to reparameterize always to make sure 0 and 1 beginning and end. All right. So have the curve, and then the next step I'm going to do is subdivide. All right. You can see this name is a divide curve. It breaks a curve based on certain numbers. So the n is an integer, which give the value 7. So if I drag this number, you can see I can provide more subdivisions or less subdivisions around the curve. Does that make sense? You basically subdivide this into sequence. So this is the input. The output, the p-value, is a point. Right? So if I roll over, you can see x, y, z. Right? X, y, z values for each point. So right now I have 23 points. Right? The reason is I divided 22 times. You got 23 points. All right? Okay? So for each point, I'm going to put a break. I say I want to duplicate the break. I will relocate the break from its centroid to the new place. The new place is along the curve. All right? So for the break, the first thing I want to do is I want to figure out where is the center point. Right? So this component, the name is a volume. It will compute the volume of the break as well as a centroid. If you actually roll over, you can see here is a name, centroid. Right? So if I click, you can see the point, right, the center point. So just make sure C is a centroid. So I will using the centroid as a point A, right? I will use a sequence of points along the curve as point B. So be careful. In this case, A is 1 point, B is 23 points. All right, so you have 1 point as A, reference to 23 different points. And the G is a geometry, which is a break. So if I click that guy, you can see the break will be moved along the curve, or duplicate along the curve 23 times. And I can drag this to control how many breaks I want to put along the curve. Question?
What's the piece you use to do the semi-point line?
The code is volume.
It's called volume.
Right. Correct. Yeah. You can also double click and you just have volume. Right? It will just pop up all the related components and then you choose that guy. So this is the one you can get a centroid for 3D objects. For 2D objects is area. That makes sense? Area will give you the centroid of a shape, enclosed shape. Other questions? Yeah, go ahead.
So if there's a mesh volume and a mesh area, so why would you not choose those if you're have one center of the mesh? Does it not matter?
Why I use the center point of a mesh?
So, yeah, so why if there's a so when you put volume or mesh area and that area, why would you so then volume is mesh volume?
Oh, I got you. Area basically is a 2D, and volume is 3D.
Yeah. So, but if you had like a plane, what and it was mesh?
That will work.
So okay.
Yeah. Yeah, if you have a 2D, you will use a mesh area that should work. In fact, if it's a box, the mesh area will be the bottom.
Not the center.
Yeah, not in the middle, not in the center. It's at the bottom of the mesh. Yeah. Okay, so one's 2D, one's 3D. All right. So that's about the first one, right? Really simple. I will disable this guy. I think if you understand the first one, the second one will be pretty straightforward.
That was a raised curve.
The last one? The last one name is orange.
Just orange.
Yes, orange means you need point A as the original point. B is a new reference you want to put in. Then just move the object from A to B. In this case, I move from 1 point to 23 points.
Okay, I see.
Yeah.
And that's how it's different than array then?
It's different from array. In fact, I have array later. I will talk about it.
Right, then.
Yeah, it's different. So the second version of the break wall, I will go a little bit faster for this one because most part is the same. So again, I have the curve, right? And then I'm using a new component. The name is a perpendicular frame. If I click, you can see Grasshopper will actually chop these curves, right? Perpendicular. And then you can have the control about how many perpendicular frames. Frame in this case is more like a plane. It's like a surface perpendicular to the normal direction of the curve. So I can control how many vertical planes I can have. Then I use exactly the same thing, right? I have the mesh break. I figure out the center of the break, and then I orient the break based on these frames. Because the frames are perpendicular to the curve, so you can see all the breaks right now is rotate 90 degrees. It's kind of perpendicular to the curves as well. This is slightly better because the curvature of the curve will actually drive the orientation of the breaks. Right? So I can do a test. If I do a PO on, points on, PON, if I change the curve, you see the break will update. Okay, so now is a little bit like a linear process. Right? You finish one system, and then later you can just reconfigure the original curve. You got a different result. It's pretty cool. All right, so this is the second version. I will use POFF to turn off this control point. So let me disable the second version and show you the third version. The third version, again, is very similar as well. You take the curve, and this time I take the curve in a horizontal plane. So it's not perpendicular. It's actually all flat in the X and Y. Okay. And again, I have this number to control how many. And I have the break populate the points. So you can see this time all the break, they are not rotating perpendicular to the curve, right? They follow the curve. And you have the number to control how many breaks. So in the reality, this is actually pretty close, right? If I want to lay out breaks, I will just, if I have a curved wall, I need a lot of breaks, head to head, like this fashion. All right, so this is version number 3. Disable that, and then I will show you version number 4. Okay, there's many different versions. This version I will use a little bit different technique. The same thing is I take the curve, okay, and then I'm going to use this component. The name is endpoints, which will extract 2 points from a curve, start points and end points. So S start, E is end. So take 2 points from the curve. You can actually see they are here. Right, the green one, right, start, end. And then I'm using the same thing. I have the break. I figure out the center point of the break. But this time I orient the break to the start point. You see, this A and B, right? A is the original centroid of the break. The B is the start point. It's the start point of the curve. So you can see right now the brake is being laid at the beginning, at the start point. Okay? And after I do that, I can have a new component. The name is curve array. So basically it's duplicate objects based on a curve. Right? You have to know what is the input, right? The input, if you are not familiar with this new component, you can always right-click, choose help. Right-click, choose help. Then will pop up some message. So it tell you G means geometry. Right? In this case, it should be the brake, right? Curve, of course. N means how many numbers, right? How many times you want to array along this curve. And also give you some output. All right, so in this case, I see I put the brake as a geometry, I put the curve in, and N is actually 16. So if I click that, it gives me exactly the same result, and I can drag this to control the brake. Smaller number, bigger number. Right, so the result is actually the same as the previous version 3. Version 4 is the same. I showed you this, it just tells you the parametric design is not really like a one linear thing, right? You can have many ways to build component. You can have more or less controls, depends on the parameters. All right, so this is a curve array. I will turn off this guy. Any questions so far about put brakes along a curve? Seems like a pretty straightforward, right, process. Curve array, you have to get the latest version. Okay, I think based on the I forgot where is that. Oh, here, array. There are many different ways you can create an array. It's like a duplication. Okay, you have to get the latest version of Grasshopper. The next thing I want to show you is more complicated. This one is actually has a much more control. You can have the brake wall. So I will show you what's the end result first. So just give you an idea. So this is the brake wall. So except well, this wall is actually multiple layers, right? The previous version you only have one layer, but this one I have multiple layers. The layer is actually controlled, like I show you, is simple, is by array along the z-axis. Right, so this is actually a component allow you to duplicate result along some direction. So in this case, the direction is z, right? And you have this control is distance, how far you want to move the duplication. So you can have higher, lower brake walls.
Is that just a vector?
It is a vector, right? The vector means is a direction, like an axis. To tell you is z-axis. And n value is the count. So right now is a 10 by default. It will duplicate 10 layers. If I right click, I can set the integer to 5. Then you got 5 layers. It's simple like that. If you want, you can also using a slider to control it, right?
Is there a way you can control a vector without setting, without doing the actual Rhino? Is there a way you can just set it as XYZ in Grasshopper and it will automatically recognize it? Or do you have to set it up in the Rhino?
You have to set up in Grasshopper.
No, I mean when we set that, or it's just a unit Z, is that a different one than the base vector?
Oh, it's just unit Z.
Oh.
It's not a base vector. It's not a vector loaded from Rhino.
Oh, I see. Okay.
Yeah. See, when you type, maybe I shouldn't skip, jump too far. the z vector or the z axis, if you actually tap z, right, double click tap z, there's a bunch of component related to z. So unit z means I will define the orientation of duplication along z axis. So that's unit z. The f is actually control the factor, is how far the z axis should be. Is a shorter one or is a tall one? Then you control that with f, the factor. Default is a 0, is 1. Question?
So if the curve, so right now your curve is in the xy plane. So if it like started in that plane and like went up to get like going to the axis, how would you do that? Would you still like?
Okay. So the question is, if the curve is not in xy,
It's not the same plane.
it's not in the
Starts
same
one
plane.
and finishes it, correct?
Yeah, if it's a 3-dimension one, if you still duplicate along the z, it will just put one layer on top of another one, straight
So
on.
could you like move a vector that's like perpendicular to plane curve?
Possible. Then you have to build up other component. You shouldn't using the z anymore. You might using some kind of normal direction to move.
Also, what if you change your C-plane while you're working on it? Will that affect what the unit Z is? Or the unit
No,
Z?
it wouldn't. This is in Grasshopper, so whatever you changed in Rhino, it wouldn't be recognized
Thank you.
here. Good question. If you want to go the negative one, you can make, well, you can do this. You can take this duplicate twice. Right? So one, I can show you. It's Control C, Control V. You can duplicate twice. So for the second one, I should actually duplicate all three. Right. So for the second one, you give this guy to -3. Oh, I should define the minimum value to negative. All right. So in this case, it will move the z down, and then if I take a look at the result, you got this push down. If I highlight both, you got both. So sometimes you could add additional component into this process. All right, so let's continue. We got a rough understanding. This is one layer. We just duplicate along the z-axis, right? But look at this part. This part is actually more confusing. For the rest, it's pretty much the same. So at the beginning, I have the break, and I put the break, duplicate along the curve, right? Use array, and then I duplicate array along the z-axis, so it's moving up. But this part is confusing. Let me explain a little bit. This one allows you to control the rotation of break individually. Okay. So let me explain. So number one, as you know, if I just go to the layer number one, so how many breaks I have? If I roll over 20, right? I got 20 breaks along the curve, correct? 20 breaks along the curve. And each break, I can, find out the center point. And then I want to rotate each break. I have 20 breaks. I want to rotate break. So here you can see for this G, 20 breaks, I feed into this rotate component. Right? If you're not familiar with rotate, right click, help. It will tell you the geometry is the 20 breaks. The A is a rotation angle, and the P is a plan. Right? By default, the plan is actually the XY. So in this case, I have 20 breaks, and 20 breaks has a 20 center, right? 20 center point. the center point became the rotation points. So all the breaks will rotate based on its center, right? But the rotation value, the A value, I want each break rotate different values. If I roll over to the A, I see 20 values. I have 0, I have 6, the value here, if I roll over to this guy, is computed based on a color value. This is actually very confusing at the beginning. So what is the color value? All right. So we know we have 20 breaks, correct? And I will use 20 as a number to create a sequence of points, from a sequence of values from 0 to 0.45. Each one I just increase 0.05. It's just a sequence of number. And then I put this sequence of number. You see, you have 20 numbers. Each number is increased 0.05, right? I put a sequence of number into this new component. It's a gradient color. It's from black to white. If you imagine this number will align along this axis, right? Just like a sampling point along the axis. So these 20 points, each one will have a different gray color, right? The first point will be black. The last point will be white. You also have 20 points in the middle. That makes sense. So you have 20 points, 20 color. And this 20 color, I will use this component to extract the RGB, the red, green, and blue. Because it is gray, it actually doesn't matter. RGB color is the same. Right? For gray color value, RGB is the same. So red color value, if I feed in to this panel, you can see the red color or the gray color is from 0 to 1. Right? The one on the right is actually 1. The one on the left is 0, which is black. So that's all the numbers I have. And then I feed this number into the rotation. So 20 breaks, I have 20 rotation values, right? So the first break will rotate 0 degree. The last break will rotate 1 degree. Okay, so that's the meaning of the sequence of values. However, here I add a little bit of mathematics. The name is expression. In fact, I can right-click, write expression. So the A value came in, I multiply with pi, and multiply with 2. The reason is I want to make that value be 360 degree rotation. So 0 will translate into 0, and 1 will translate into 2 pi. Right? That is a full rotation. Got it? So this is actually rotation values I feed in. So as a result, you can see each break, they will rotate in a different orientation. So the first one, there's no rotation, right? It follows the orientation of the curve. And the last one is actually rotate 360 degrees, is opposite direction. And you have everything in between. The benefit to have a color to control that is the color could be squeezed in one direction or released in another direction. So by that way, you can actually control the real time about how the breaks. If I keep everything as black, it will just follow the orientation. But if I change everything to white, follow the other one, or I can make this, ease in, ease out, right, based on the color.
What reads the color again? Is that a color component?
This one's a gradient. Is basically this guy.
And then the one to the right of it?
On the right of it, this guy is the split RGB, split ARGB. A means alpha, which controls transparency. R is red, G is green, B is black, B is blue. Okay, So this is basically you take a color and then you extract the channels from that color. If anyone familiar with Photoshop, you should know, any color is actually a combination of RGB, right? Or CMYK, either way.
So since the gradient is slider is just black and white and they're ultimately the same, do you need that for the splitter?
I do need the splitter. Here's the reason. If I don't use it, I will just type a panel. Panel is basically kind of like a quick preview. If I don't use a splitter, you basically get 3 values per color, right? It's RGB value. I only need 1. That's the reason I want to split. Also, the value displayed between 0 to 256. That is actually the typical index for colors. But if you split, it only compute between 0 and 1. So it's a little bit easier to work. Right, so the before the split, RGB, right? You see the red, green, blue is actually the same because it's gray color. But after I split color, you got only 1 value. That is the red color channel between 0 and 1. I know it's a little bit confusing. It's just the way Grasshopper, build up this component. Theoretically, this, maybe between 0 and 256, it make more sense, but that's how it works. Okay, that makes sense. I think this might maybe a little bit confusing. Later, you can definitely, play with this script. Just keep in mind, the idea is I use a color-controlled orientation. So black and white will control how many degrees each break will rotate. Okay? So let's go even further beyond this one. Right now, each layer above the z-axis is a duplication of the layer underneath, right? So they look identical. However, I want each break will be different. Along the z-axis, I don't want to using the same value. I want each one rotate along the z as well. Okay? And also, I want to use color to control it. All right? Not just manually do it. I want to use a color. So instead of using the gradient, which is I would say is a one-dimension line, right, from dark to bright. In this case, if I want to do a 2-dimension control, I should be using this new guy, right, image sampler, which will give me the information on a 2-dimension surface. Okay. So let's talk a little bit about this final one. This will be the last one in today's demo, which is actually more complex. Let me just turn on the, let me just enable that, and I will show you the final result. Actually, I didn't use the curve. I used the straight line here, but maybe that's just using the curve. Why not? It's more consistent. Set curve. Okay, so this is the result of the brick wall in z-axis. The rotation, each one is different. It's also controlled by an image. All right. So let me explain a little bit. Before I do that, it is a resemble of a this happy face. You maybe already tired of this image, but let's just using it right now.
Does it use a bitmap to use a vertical gradient to equally align?
Yes, you can do that as well. Yeah, but this one is more flexible, in fact, because you can paint directly in Photoshop, right? And then you're using that color to manipulate. But you are right, you can do that too. So here, it really depends on how many breaks I want to put in. You can get a actually pretty accurate representation of that image. just by changing orientation of the brake. Okay. So I will explain a little bit piece by piece how I build up this definition. Also, you see I create two base for the wall. So at the bottom you have kind of sort of like a slab, kind of like a ribbon-like slab, and also I have a top, a head here. This is all built up in Grasshopper. The only variable, actually two variables you can control. One is a curve itself, right? It's a straight line, it's a curve. You can define a curve. If I build up a new curve, I can just simply set to the new curve. Oops. So the wall will update, the roof will update, the base will update. So this is one variable, is the curve itself. The second variable is actually the how many brakes. So right now, if you multiply 24 by 42, roughly we have 900 brakes. You can reduce the number. If you have too many brakes, I can just reduce. So you have less brake. Okay, so that's the control here. Again, let's actually I want to reset back to that curve. It's easier to see this curve. Okay, so let's explain a little bit. I will start with the curve. All right, the first thing I do, let me just turn on the green box. So first I do is load the curve in, right? Simple. And then I move the curve along the z-axis. Just move it up. So here's the z, and here's the distance I want to move. So you can see the curve has been moved up, right? So I have two curves right now. And then I did a loft. I think I covered this last class, right? Loft is basically create a surface based on two curves. So you get a surface. And then this surface will be fed into this component. The name is divide surface. So right now this surface has only one subdivision, from left to right. But however, I can feed UV values. I have 12 divisions along U, 20 divisions along V to subdivide this surface. So you get more points on the surface. So you can see right now I have 273 points on the surface. If you multiply these two, you roughly get the number about the points on the surface. And then I use the UV value of these points to map on this image. So I basically figure out this 273 points. What is the gray color value? Question?
When you reparameterize the surface,
Yeah.
what does that mean for it? Because it's kind of lines, it's kind of 0 to 1. Where 0 is the center and then 1 is the outline of the surface? So how does that work?
Yep, a good question. Reparameterize a surface means I put 0, 0 in one corner. By default, this will be 1, 0, 0.
Okay.
And 1, 1 after reparameterize should be this corner.
So does that mean that all the data we're going to have to plug into that one is going to have two values now instead of one value?
Yes, the UV value is actually two values. It's actually 3, UV and normal. In this case, our normal is 0 because we are not pushing the points against the normal directions. You can see after reparameterize, all the UV values is between 0 and 1.
And then you're flattening it so it stays lined up, right?
Yes, and then I flat them and feed into these image samplers. So that's how you can project, right? It's sort of like a project. These 273 points against the image, and then you figure out what is the gray color value per point. So at this result, I have 273 points. And then the next thing I do, I think I have to talk a little bit about this part too, is I simply move all the breaks into these 273 points. Right? There's no rotation, it's just a straight move. Right? They follow exactly the same orientation of the break. And then I figure out the center point of each break, and then I will orient the break based on some degrees, which is easy. But hard part is what exactly is the orientation, right? The A value, the rotation value. We know you have 273 breaks, you have 273 rotations. So, but what exactly is this rotation value? This rotation value is actually directly extracted from the color. So if the color is black, it's rotate 0 degree. If the color is white, it's rotate 360 degree, or 2 pi. 2 multiplied 3.14. That's a 360 degree. So basically, I feed in this gray color value directly into the degree, but with an expression. So the expression here is multiply 3.14. Actually, I should multiply 6.228, but no, this is okay. This is only rotate 180 degrees for the white. If you want to rotate 360, you should multiply 3.14 and 2. That makes sense? So this is how you translate the floating point into rotation degrees. Alright, so each break now is rotate differently. That's actually pretty cool. I can definitely update the image. I can double click. I can switch image to a different one, right? Then you can see the rotation will be different. Just make sure you always stay with the brightness value, because you only care about the gray color. So brightness. And here's all the breaks. For the other part, this part is actually pretty straightforward about the top and the bottom. For the top, I create a loft, I create an offset. This is exactly like AutoCAD on both sides. So in and out. And then merge them together, I create a loft. So that's how I get a surface. And then extrude the surface along the z-axis, so you get a little bit depth. And then at the end, I merge everything together. Use merge. Again, let's go back. I can, tweak the number of breaks. I can tweak the number of breaks along the U, along the V. That looks pretty good. That's how you get a break. Right. For the rest part is actually how I extract this rotation value into a kind of like a spreadsheet, because I do want to print this number out in some point. So this can be copy paste into Excel or Word. Actually, I did a sequence of mathematics. So at the end, this is actually the rotation value of each break. So the break number 1 rotate 144 degrees, for each break. Some break rotate 0 degrees. And this can be printed as a guideline for the workers. Right? Question?
How does the break motor operate within what is the base and the break? How does it know? Is that the 0 to 1 value? That's how it knows how to operate within the two curves. They're lofted. It's lofted between the two.
Okay. Y is lofted along between the top and the bottom.
Yeah.
Okay. It's because I use the surface. This is the lofted surface
Right.
to populate the break, right? And this surface is exactly the same one I built up the top and the bottom. So they're actually using the same curve. Yeah, that's the reason they match. This is actually pretty interesting about parametric design is one variables can fit into different branches, right? And then you have this kind of coherent correlation between. Question?
You want to create like a wall, like reinforcing, like running log or something?
Right.
Could you short the wall?
Not today, but that will be a totally different component because you have to do half, right? And then the other layer you shift to the other half. It's doable, yeah, but it's very different from this one. I assume in that case, at the beginning when you populate the breaks, let me just reduce the number. It's easier to read. Okay, so at the beginning we'll populate the surface without rotation. There should be some compute is every other layer. I should shift the breaks halfway, and then you rotate. That would be some logic there. All right, so last step I want to actually bake it just to show you what the break looks like, and then that will conclude today's demo. So I just give a little bit more breaks, make it look cool, and I will just bake the final one. So bake layer 4. Right after you bake, you can basically close Grasshopper, and when you turn on layer 4, you can see this is all the breaks. I will turn on the rendering so you can get a sense. It's a little bit too dark, but you see these are all the breaks. It's actually pretty cool. This is all the breaks. You can still see the face, can you? Somehow. All right, I think that's it for today's demo. Let me turn off the Grasshopper.